Hello everyone. From a previous post on Synergio, how the mite is positioned in the regular tetrahedron center and an octahedron center. This is minimum all space filling tetrahedra as the lowest common denominator mite equals quark. I am referring to this rendering So this is again a nice picture and a strong claim, but on a paper, but wrong in the real modeling. Octet, which is composed in this case from a quarter regular tetrahedron, is this one, and which is 6 blocks in Synergetics, and an octant, which is 12 blocks in Synergetics, equals 18 modulus, goes together like that. This is called octet. In my system, this equals 12 modules, so we have 18 versus 12. Werner claims that it is better to have more modules despite the lowest common denominator claim. What an oxymoron term. Well, it is not better to have more blocks in this or any other case and do less with them. That is not but constitute any parsimony principle, except in Synergetics. None or most of what you will see now is not known to any Synergio enthusiast or any devoted scientist, since no descriptions of this kind have ever surfaced. Synergetics makes these claims because no one had challenged them. That is what confirms our originality. Now, I want to show 6 mites, and we're going to build an octet. I mean, yeah, these are mites. I don't even like to use the term mites, but I want to jive with Synergetics. So we have 6 mites in here, and this is how we're going to make our octet. We're going to fuse these together like that. And then we're going to do the jostle them like that. And there we have our octet truss. We have our octet, which is of course same like as this octet, but this is built different ways, but they are same structures. And there are other ways to build that, and I'm no Synergetics or Synergio people have no clue about that. Now, so this is made of 6 mites. Now I want to fold this together like this. And we ended up with 2 cubes, as you see. These are 2 cubes. And this is not possible in Synergetics at this level, no way. Now, let's do the other rendering. Now remember, I'm using octet now. This is a rectangular solid. These are the same modules we just built. I'm doing it on a camera, so we see it. This is a converted octet into a rectangular solid. Not possible in Synergetic. Now let me go put it back. We make these 2 cubes. Okay, now folks, please watch it. This is 2 cubes, and we see that in this section in here we have 2 mites. Now when I rotate it, there is no mites in here, but there is these 2 mites in here. Now these 2 mites represent quarter coupler or the oblate octahedron, and 2 cubes represent 1/4 of the 2 frequency cube. So if we would stack these, more of these cubes, 4 of these, just like that, all around this center axis like that, we would end up with the top and bottom centered coupler inside the 2 frequency cube. Now, if I rotate the cube 180 degrees, we see that the coupler disappeared, and different structuring, we would arrive at different structuring if we would have 4 of these cubes like that. It would just be different. But anyway, I showed you the quadricoupler inside the cube, and it would, like I said, it would be a top and bottom centered cubic, not ever seen in Synergetics. Now I also want to know that in Synergetics this octet constitutes 18 modules. In here, since Synergetics cannot do this, but in reality we see that there are 2 cubes, and we said 18 modules, that means each cube would have to have 9 modules. That's the formula in Synergetics, that 8 nines. And again, just because they cannot model this, they almost don't believe these demonstrations. Now here I want to go back, and you see that this is our rectangular solid, as I have it earlier. This is our rectangular solid. Now check this out. I split it like that, and we fuse it like this. Now we have these 2 rectangular solids stacked up, but they're still rectangular faces. Sorry. This is a square. So isosceles triangles in it. So this is basically a prism kind with the triangular base. But let me add 2 more mites to it, and I'm wondering if anybody recognizes what's going to happen in here. Now we see this kind of structures, still same base, and this is how this looks like. Now remember people, 2 rectangular solids are stacked in here, 2 rectangular halves, this way or this way. Now does anybody recognizes what this is? Let me help you. We're going to put these solid kites in here. This is, I'm adding on. Now this solid kite is also a module from an octet truss. One way to build it. Voila, we have a half cube octahedron. So we see how 2 rectangular solids can end up into a half octahedron. Now here I put the octet back together, and I just want to show the edges. We should all know these edges because this is the lowest common denominator, not what Synergetics claims, but this is. And I want to show these edges. This is a square root of 3. This is a square root of 2 up to half, and this is a z cube or a Synergetics cube, which this would be square root of 2 in Synergetics cube, if that would be its edge. But in my system this is the edge 2 because it contains 8 cubes. It's a 2 frequency cube. This is the other kind of prism, again folded from that same octet truss.